Alright, I thought this was a perfect time to put together a little presentation and show what my vision is for hydroxy fuel, what the point is of all my experiments, and what you can expect to see in the future from it. So I put together a little presentation, here it is. So what keeps me motivated to spend every spare minute I have researching and experimenting with this gas? Well, in 1995 I remember hearing about a newscast about a woman in our city that had died from carbon monoxide poisoning. And it really impacted me that a appliance that is supposed to be heating her home could actually be throwing poison into her home while she slept. So as I got in the trades and I took a gas course, I realized how easy it really is for people to get poisoned by carbon monoxide and how common it is. So I developed a hatred for all fossil fuels that create carbon monoxide, especially the ones we're using in our homes. It bothered me to the point where I didn't even renew my gas license because I didn't want to take part in these appliances that had the potential for poisoning somebody. So every experiment that you see on my channel is going to be devoted to getting carbon monoxide out of the home, and it's all going to be under one of four headings: clothes drying, cooking, heating, and electricity. And that's what we're going to be focusing on. So let me go into each one a little bit just to explain my vision, starting with clothes drying. So gas heated dryers either use natural gas or propane to create heat, and both have a byproduct of carbon monoxide. If you focus just on the diagram on the left, that illustrates how a gas dryer throws its heat. A gas flame throws its heat into a channel, and then out those little holes on the top, it goes right into the drum where your clothes are. My goal is to take the existing setup and just simply funnel hydroxy through there, and if there's some small additions I have to put on, that's fine. But you may even recognize this gas valve system with the pipe coming down. I have it on my workbench. You might have seen it in previous videos, but I'm actually going to work with that valve to try and get it to funnel hydroxy gas. And once I've dialed that in, then that can be applied to all commercial laundromats that also have natural gas dryers, and they can throw away their carbon monoxide detectors for good. And I do have one other goal as far as clothes drying. I want to make a type of closet type dryer that you can just hang your clothes in and they dry where they are. Now the next goal is cooking. And just like drying, on cooking I want to use the existing natural gas burner on stoves and in ovens and just convert them to run hydroxy fuel through there, and then we can stop the carbon monoxide potential from coming through. In my videos you've already seen where I've taken a burner from a natural gas stove and just used the bare guts of one and actually cooked pasta with it, so I have proved that it's possible, and we're going to go way further with that in the future. So another area in cooking where we can get rid of fossil fuels is the barbecue. I want to convert the barbecues to run on pure hydroxy fuel, and that'll also get rid of the fact that there's an explosive canister underneath the barbecue every time we're cooking. And if nobody knows what a propane tank is capable of when it explodes, just go on YouTube and type in propane explosion. And once we've done a successful conversion of a barbecue, we can bring it into the home since there's no toxic fumes that come off the hydroxy flame. Just imagine an indoor hydroxy gas barbecue built right into your counter. So now that brings us to the next goal, which is probably one of the biggest ones of all, which is heating. And heating is covering everything that makes heat in your home. Not just home heating, but pool heaters, saunas, everything that can possibly use heat in your home. We're going to use hydroxy to create that heat instead. So home heating is a place where I think we can make the biggest impact of all, because the natural gas forced air furnace is responsible for more carbon monoxide poisonings than any other appliance. And that's because, as you see here, the gas flame is made in one chamber which heats a metal shield called a heat exchanger, and that heat is absorbed right through to the other side and picked up by flowing air and funneled into your home. So those two chambers have to be kept separate. One chamber is the natural gas that has a byproduct of poison, and the other side is just pure breathable air that's just being heated by that piece of metal that's being heated by the gas flame called a heat exchanger. The problem is, if that heat exchanger even makes the smallest crack, carbon monoxide is going to start funneling through your house while you're sleeping and is going to poison you, and it's totally colorless, tasteless, odorless. You won't know it's there unless you have a carbon monoxide detector, and if you don't have a carbon monoxide detector on every floor, then it's useless. Another common thing that happens that causes people to get poisoned with these forced air furnaces is they'll do a renovation in their house and they'll create a negative pressure in their house. So instead of the natural gas fumes going up through the chimney, the air pressure is actually creating a vacuum, so it's pulling air from the chimney into their house, therefore pulling the carbon monoxide into their home. We've had 3 families die this year already in the city that I live in because of this. And believe it or not, it could be easy as a bird building a nest on the chimney of your furnace, and that way the carbon monoxide can't escape, so it backs up and funnels into your home, and people die that way too. So there's no point at all that we should have this primitive poison being pumped into our homes all across the country. It's a total nonsense. We have a way to change this, and we're going to do it. So like I said before with the other appliances, my goal is to keep the furnaces in everybody's house that already exist, but let's change these natural gas burners into hydroxy burners and simply heat that heat exchanger the exact same way. Nothing has to change, and that way if a heat exchanger does crack a little bit, it's not a big deal because you can completely breathe hydroxy gas without any problems at all. And obviously the exact same thing applies for natural gas fireplaces. You just want to use the same burner but convert it. Like I said earlier, there are other places in the home where we use natural gas or inefficient electric heating to create heat for different reasons, and we're going to convert all that to hydroxy. Let's take a look at some of them. So anyone who has a pool and heats their water with natural gas will recognize this as a pool hot water heater, and it works with very much the same principle as all the other heaters that we've been looking at. You just see your natural gas burner, which can easily be converted to runoff hydroxy. We can get rid of that. Also, people have hot tubs, and the same heating process is used for hot tubs as pool heaters, just a natural gas burner. And there's also other options of solar hot water heaters for pools, which is great, but if there's not enough space for that, we can convert the natural gas ones to runoff hydroxy. So another place where we use natural gas to provide heat in our homes is in our saunas. A lot of people have natural gas heated saunas. This is an example of one here. The other option is to go electric. And here's an example of an electric one. The thing I don't like about electric heated saunas is you get a very dry heat, and it's not good for saunas. You can see the elements that it uses are exactly the same as what you'd see in a stove or a hot water tank, so it's not an efficient system at all. And one big benefit to a hydroxy heated sauna would be that you wouldn't have to vent out any exhaust gases, and you would at the same time be humidifying the air within the sauna. Now, to heat the hot water in our homes, we usually use natural gas hot water tanks. And you'll see in a second here the diagram of how it breaks down. It's just a simple gas burner again underneath that's going to heat through metal. It's going to heat the water that passes through the pipe. And if you look at the top, once again, we've got a vent pipe because we have to vent out all the poisonous gas as the byproduct of natural gas. And just like everything else I've shown you, there's no reason that if a gas burner can heat the water, that a hydroxy burner can't do the same thing. Now there is a safer way to heat your water. That's an electric hot water tank, but boy is it inefficient. It uses a lot of energy. Now another way to heat your hot water, which I really like, is an on-demand hot water system like this, which just uses natural gas burner once again to heat the water that passes through it, so you get your water, your hot water, as soon as you turn your tap on demand. And there's no hot water tank storage. This is a very efficient system, and as you see, we got another gas burner that we can change to hydroxy. Now, a hydroxy-fueled on-demand hot water system coupled with a solar heater, which actually allows you to have a reservoir tank, I think is the best option possible. Here's some solar heaters that can be put on roofs. There's all kinds of different solar heaters that are coming out now, and I think this is a huge, huge benefit to society. And I think anytime we can couple solar power with hydroxy, I think you've got the greenest, best solution for our future. So far, by concentrating on clothes drying, cooking, and heating, we've been able to get rid of poisonous carbon monoxide gas and replace it with a fuel that has a byproduct of water. So let's take a look at our last goal of electricity, and then we'll get into some really exciting stuff, and I'll tie everything in together.